Okay. We are recording. So first of all, I want to talk about the lab. So I ask you to email me the information of the people that are going to be in the groups, no? So up to now, those are the group that we have. So in group 1, we have Natalie, Fanny, Jeremy. In group 2, we have Peyton, Ryan, Paul. In group 3, we have Stefan, Tajudlin. In group 4, we have Bailey, Tiffany, Stephanie. Group 5, we have Timothy, Daniel. Group 6, we have Marquez and Andrew. So if you have not sent me this information, please do it, okay? We can have 2 or 3 people. So there is something that is important. I did mention that by email. I did tell it in class also. This is a group work. When you send me an email that is related to lab, be sure you copy to the other people that belong to your group. Okay, if you don't copy, it's like you are ignoring your peer because you are not copying to your peer. So even when you tell me the information of the group, you should copy the other students that are in the same group because they need to know that you sent an email. Okay, so many of you just sent me an email. One person sent me an email saying this person and this person and this person will be in the group. But I did tell you that several times. This is a work that you will be doing between several people. So any question related to labs, you should copy. Okay, because you are not doing the work by yourself. You are doing the work with other people. So these people need to know what you are telling me and what is my answer. Okay. Okay, we are going to continue with the lecture today over Ethernet. Okay, this is the agenda. We will see 5.1 and 5.2 today. We will not see 5.3, which is the address resolution protocol. That will be for another class. So, Ethernet. Ethernet is defined by the IEEE with 2 standards. So, what is Ethernet? Cover the first 2 layers. So the 802.3 cover layer 1 and the lower layer of the lower sublayer of the data link layer, which is the max sublayer. And the upper layer of the data link layer, which is the LLC sublayer, is covered by IEEE 802.2. So Ethernet at the end is these 2 layers cover Ethernet, but we need 2 standards. The first standard cover up to layer 1.5, and the second standard go from layer 1.5 to layer 2. So Ethernet has different standard, different bandwidth. So the first that we used in the past was 10 Mbps, 10 megabit per second, and we call it Ethernet. Then we came out with a new standard, which go up to 100 Mbps or 100 megabit per second, and we call it fast Ethernet. Then we have 1000 Mbps or 1 Gbps, and we call it 100 megabit per second, or we call it gigabit Ethernet. Then we have 1000 Mbps or 10 gigabit Ethernet, and we call it generally 10 gigabit Ethernet. We have all the flavor now of Ethernet that are even faster. 40,000 Mbps or 40 gigabit per second. And we have 100,000 Mbps or 100 gigabit per second. So remember that it covers both layers of the OSI model, no? And this sublayer, the LLC sublayer, normally is totally implemented in software, and the max sublayer is generally implemented in hardware. So this sublayer allows us to make all the upper layer independent of the hardware. This is very important, not to be independent of the hardware from layer 3 up. So here it is implemented in software, the upper sublayer, which is the LLC sublayer. I just told that to you. The max sublayer is implemented normally in hardware, no? This is what we have typically. And it is in the network interface card of the device. So Ethernet defines some responsibility. And those responsibilities are data encapsulation and the way that we are going to access the medium. So when we talk about data encapsulation, we talk about frame delimiting, how we are going to start the frame, how we are going to end the frame. We also have addresses there, which are going to be the destination MAC address and the source MAC address. And we also detect error in case of transmission due to noise, no? So if we have, for example, some electromagnetic interference or some radio frequency interference, we will have an error in the transmission of the frame. Data encapsulation deal with the problem of error. Now, the method to access the control deal with how we insert a frame inside the medium, how we remove the frame from the medium. And as you know, the method that we use in Ethernet is called CSMA-CD, which stands for Carrier Sense Multiple Access with Collision Detection. So Ethernet have evolved a lot, no? It started in 1973, so many years ago, as you can see. And it have evolved a lot. So the first version that we have of Ethernet was the one that we call Ethernet. Today it's considered very slow. At this time it was fast, it was a revolution. But today it's very slow. 10 Mbps is very slow comparing to the new bandwidth that we have. But the newer version of Ethernet operate much faster, as I was saying, like 10 gigabit per second, even 100 gigabit per second. Now we have. So this is the PDU of Ethernet. It's very important that you understand all the field that we will have. So first, we have a field of 6 bytes, which will be the destination MAC address. Then we have another field of 6 bytes. It will be the source MAC address. Then we have a field of 2 bytes. It is called the type or the Ether type. And here we are going to put an identifier that will say what we have inside Ethernet. So what will be, it will identify the payload of Ethernet, what Ethernet is carrying inside. So here we have the field for the payload. This field have a variable length. It can go from 46 bytes, which will be the minimum, up to 1,500 bytes, which will be the maximum. And then we have the CRC, the cyclic redundancy check, which is a field of 4 bytes. So when a frame arrives to a destination, the destination device compute the CRC and compare the computed CRC with the one that is there. If they are equal, the destination station will assume that the frame did not suffer change due to noise. Now, if the CRC, the computed CRC is different from the CRC that came with the frame, the destination is going to drop the frame, and it does not tell anything to the sender. It just drops the frame silently. So I want to go back over the payload. We say that the payload is a minimum 46 bytes and a maximum 1,500 bytes. This 1,500, we call it the MTU, the maximum transmission unit of Ethernet is 1,500. So you remember why we have a maximum, no? Because we want to avoid starvation, and we also want to avoid retransmitting something that is very long in case of noise, no? If we have to retransmit it. So if the data that I want to send through Ethernet is smaller than 46 bytes, I'm going to do padding. So I will fill the rest up to 46 bytes because this is the minimum that I should send. So if a station receives an Ethernet frame and this frame is smaller than 64 bytes, so the 64 came from 46 plus 2 plus 6 plus 6 plus 4. This will be 64 bytes. So if the frame that I receive is less than 64 bytes, this is a frame that should not exist, because the minimum frame in total, when you add up 46, when you add up 6 plus 6 plus 2 plus 46 plus 4 is 46 bytes. So if I receive a frame with less than 46 bytes, I will consider that this is a frame that went into a collision. So I will drop this frame. I will not consider this frame. Now, Ethernet do allow us to have frames that are longer than that, which means with a payload that can be more than 1,500 bytes. Those frames are called jumbo frame. So Ethernet do have a possibility to work with jumbo frame, no? So we will have to enable them if we want to work with jumbo frame. Okay, so we told that in the frame, if you remember, we will have MAC addresses, the destination MAC address and the source MAC address. So I want to talk about the MAC address again. So remember, MAC address is a layer 2 address. We call it MAC address, we call it flat addresses, physical addresses. They are 6 bytes long or 48 bits long. There is 3 ways to represent a MAC address. So you can do first byte, dash second byte, dash third byte, blah, 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 blah. Which means that you can separate the bytes with dash. It's a possible representation. Another representation that people use also is that you separate the byte with a colon. So we can have the first byte, colon, the second byte, colon, the third byte, blah, 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 up to the last byte. Now, some other manufacturers use another notation. Instead of grouping by byte, they group by pair of bytes. So in this case, they take the first 2 bytes, and then they put a dot, a period. Then the following 2 bytes, period, and the last 2 bytes, period. So this is 3 possibilities for you to write your MAC address. And when you are in an exam and they are asking you a MAC address, you can use any format. You can use this format with the dash, or you can use this format with the colon, or this format with the dot. Okay? There will be no problem with that. Remember that the first 3 bytes, sorry, are called the OUI, the Organizational Unique Identifier, no? Oh, here we do have information about that, no? So remember that who controls the MAC addresses is the IEEE. And the first 3 bytes, as I was telling you, is the organizational unique identifier. So IEEE, if you are a company, you manufacture networking devices, you will need to buy a OUI. So you go to the web page of IEEE and you buy a OUI. So how to use this OUI? So IEEE have very simple requirements or very simple rule for you to follow when you use your OUI. So you must use your OUI first of all. If you finish, you use completely your OUI, you can purchase another one. So we were seeing that Cisco system, for example, already have bought a bunch of OUI, no? And every time that you create a new network device and you need a MAC address, you have to put in the last 3 bytes a different value, which means that with one OUI, you can create up to 2 to the 24 different MAC addresses. And you cannot repeat those MAC addresses. You should not. This is a requirement from IEEE. So manufacturers do that from time to time. They do repeat the MAC addresses. But what they do, they sell the networking devices in different continents. So the probability that 2 devices with the same MAC address are installed in the same local area network is very, very low, because one of the devices will have to travel to another continent and arrive exactly in a place where we have a MAC address that already have been assigned. So they do it. They abuse a little the system to save some money, but they should not do it, no? And if at one point you find that you bought 2 devices from a manufacturer and you have a duplicate MAC address, you can write them and they will pay you, because they should not do that. So they will give you some money as a way to say, I'm sorry that this happened, this should not happen. When you want to consult the OUI, you can go to this link, no? Where we will have the first 3 bytes of MAC addresses. Remember that the OUI is the first 3 bytes, no? So, for example, if you give me this OUI, let's do an exercise. You give me this OUI, 00602F, and I want to determine who is the manufacturer. So I can go to this website. Let me copy the URL. Let's open a browser. And let's search for this OUI. So we say 00602F. So 00-60-2F. Okay, 060, wow. Here it is, 00602F. This is the OUI from Cisco system. So I can say, if you give me a MAC address that starts with 00602F, that this MAC address is a MAC address of Cisco system. Okay, so you can just take the first 3 bytes of a MAC address, which is the OUI, and you can search it, the OUI, in the web page of Cisco. So this is also a problem, that based on the MAC address, you can infer the manufacturer, because hacker will take advantage of that. For example, let's say that they want to attack a system, and they are in the local area network of the system, and they get the MAC address of the system. They will search in the web page of IEEE, and let's say that, for example, they realize that this MAC address belongs to a Macintosh. What do you think the hacker is going to say? That the operating system is very likely to be macOS. So it already have information about the system that the person wants to attack. For example, if the MAC address belongs to IBM, there is a high probability that the operating system is IUX. IUX is an operating system from IBM. If the MAC address is from, let's say, for example, HP, Hewlett-Packard. Hewlett-Packard has its own operating system, which is called APUX. So there is a high probability that the operating system that the device is running is APUX. So having information of the operating system already gives you a lot of information about what the hacker can do, because the hacker will look at some database where they report problem about the operating system and will try one attack over this operating system that have been reported. So if you don't patch your operating system or you don't update your operating system when there are updates, mostly you will be hacked because the hacker will get information of your device, no? So it's why having the MAC address give the hacker information, because they can infer the manufacturer. Of course, if the manufacturer, for example, is Cisco system, probably it's a router or a switch, and it will run the iOS of Cisco system. I don't think there is another operating system that you can install in the device of Cisco system. I don't think so. And mostly people that will run Cisco system devices, they will keep the iOS of Cisco system, no? Even if other operating systems are available and I don't know about them. Okay, so we have been talking about MAC addresses. So look at, this is the PDU of Ethernet. The MAC addresses are burned in the network interface card. So you cannot change them physically. So normally a device should use its MAC address, but of course hacker will spoof MAC address. They will change their MAC address and they will tell the device to not appear with the real MAC address, but to appear with a fake MAC address. But normally a device that behaves normally, that do not attack any other system, will use its MAC address. And the MAC address is burned in the network interface card, and it will be always the same MAC address. So it will not change because it's burned in the operating system. So let's say that this host, which is host 1, want to send something to, for example, this host, which is host 3. When it will create the frame, it will have to put the destination MAC address. So it will have to put in the frame the MAC address of the destination, which is S3. And as you can see, the MAC address here is CC:CC 6 times. So in the field here or here, it will put CC:CC 6 times. And in the field source MAC address, it will put its own MAC address. So my MAC address here appear like AA:AA 6 times. So I will put that here or here, as you can see. Okay, so H1 will send that to the switch, and the switch is a very intelligent device, as we will see today. It can do filtering, it can do commutation or flooding. It will decide what to do. But eventually, the frame will arrive to the destination, which is H3 in this case. So if you want the MAC address of your computer, in a Windows system, you can type ipconfig/all. Now, in a Linux, you can type ifconfig. It will show you the MAC address. Okay, so remember that there are 3 ways to write the MAC address. You can use the dash notation that will separate byte. You can use the colon notation and you separate byte, or you can use the period notation and you separate 2 bytes. Now, let's see a little more information. We have talked about that previously. Let's say that this computer H1 have to send something to this server. So in layer 2, it will put as the destination MAC address the MAC address of the server, as you can see it here. As the source MAC address, it will put its own MAC address. Now in layer 3, as the source IP address, it will put its IP address. And as the destination IP address, it will put the IP address of the server. Remember that this is a LAN. If it were not a LAN, if I send the packet to a remote network, remember that the destination MAC address is going to be the MAC address of the default gateway. So there is a small difference if the communication is in the local area network or it's a communication to a remote device. No? If it's a remote device, I do need the help of the default gateway, which is a router. No? Now, if H1 wants to send a broadcast to all the other devices in the network. So let's say that the network is 192.168.10/24. So H1 will compute the broadcast address of this network, which is 192.168.1.255. So in layer 3, H1 will put as the source IP address its own IP address, which is 192.168.1.5, as we can see here. Now, as destination IP address, is going to put the IP address that corresponds to the broadcast address of the network. So the broadcast address of network 192.168.1.0/24 is 192.168.1.255. Now, in layer 2, where we have Ethernet, the destination MAC address when we send a broadcast is always FF-FF-FS 6 times. So it will put that. This is the broadcast MAC address. And as a source address, it will put its own MAC address. So this MAC address means send it to everybody. This IP address is also a broadcast IP address. Send it to everybody inside the local area network. No? So there is another possibility for H1 to do a broadcast. It can use this IP address also, 255.255.255.255. This is called the limited broadcast address. Now, this IP address, 192.168.1.255, is also a broadcast address, but it is called the directed broadcast address. It works only for this network, the 192.168.1.0/24. Now, this limited broadcast address works for any network where I am in, but it will send it only to the device. It will be a local broadcast. It cannot be a remote broadcast, no? So what you have to remember is that the broadcast address, the broadcast MAC address is FF-FF 6 times, no? Okay, now let's talk about multicast. Let's say that H1 wants to send something to a multicast group. And this multicast group is 224.0.0.200. So this computer shows interest in the group and is subscribed. This one also, this one also. These two computers are not subscribed. They are not interested in the multicast group 224.0.0.200. So when H1 sent the packet to the multicast group, as source IP address, it will put its IP address, 192.168.1.5, as you can see. Now, as destination IP address, is going to put the IP address of the multicast group. So remember that the IP address of the multicast group go from 224.0.0.0 to 239.255.255.255. Any IP address within this range is a multicast address. Now, At the level of layer 2, which is Ethernet in this case, let me talk about the destination MAC address. The destination MAC address, when it's a multicast, always start with 01005E. So if I see the first 3 bytes as 01005E, as they say here, I know that this is a multicast MAC address. So there is a way to find the other 3 based on this last 3 bytes. So if you see this 0 is here, this 0 is here, and this 200 is here. So C8 is 200. 12 times 16 is 192. 192 plus 8 is 200. So there is a unique correspondence between, not unique, between an IP address, which is a multicast address, and a multicast MAC address. Remember, they all start with 01005E. So the computer, the source, will send that, and the switch mostly will forward it all the other interfaces. When it's arrived to this device will say, oh, I am in this multicast group, so I'm listening to this MAC address, it will accept it. So the other 2 devices that also subscribe the multicast group are going to accept the frame. Now, these 2 devices that are not in the multicast group do not listen or do not accept frame that arrive with this MAC address. So they will drop it. And who take care of dropping this frame? The network interface card, which means that the information will not arrive to the processor. The processor will not be interrupted to decide that you have to drop the frame. The network interface card already have intelligence, and it is able to decide to drop the frame because it doesn't listen to this MAC address. Okay, I'm going to finally define what are the devices that are in the network. So I'm going to talk about what is a hub, what is a switch, and what is a router today. And we are going to see how a hub and a switch work. So this is the representation of a hub. So an Ethernet hub, we also know it as a multi-port repeater, or simply a hub, is a network device that will allow you to connect several networking devices through Ethernet. And it will act as a simple collision domain. So what will happen is that it will have several ports, and when a station that is connected on one of the ports sends a frame, the hub will do what we call flooding. Flooding means it will repeat the frame in all the other interfaces. So a hub always do flooding. It's not intelligent. Something enter in port 5, for example, it will copy the same information in all the other ports. This is a layer 1 device, which means it does only understand bits. It doesn't know what is a MAC address because the MAC address is in layer 2. So it's a layer 1 device, and it is just a unique collision domain. What does it mean? It's a unique collision domain. You see this hub, for example, it have 1, 2, 3, 4, 5, 6, 7, 8. Okay, it have 9 ports. So I can connect up to 9 stations. Now, the fact that we say it's a unique collision domain, which means that out of the 9 stations that are connected, only one can transmit at the time. Only one. If two or more stations try to communicate or try to transmit at the same time, we will have a collision. So it's why we say it's a unique collision domain. There is only one collision domain, which means that only one station can be transmitted at a time. And it's also only one broadcast domain, which means that if you send a broadcast, if one of the stations sent a layer to broadcast, this broadcast will be received by all the stations that are connected to the hub. So a hub is a very basic device. It doesn't have memory. So there is no way for a hub to store a frame. So as soon as the hub receives the frame, the hub have to copy the frame out. It will have an incoming port, and it will copy the frame in all the other ports. So all the other ports will be outgoing ports. So today, you don't see manufacturers that do hub anymore. They have been replaced by switch. We will see why. The switch is more intelligent. The switch is a layer 2 device, while the hub is just a layer 1 device. So it's like a legacy device. I still have hub. I do like them because they are very good to teach the student what is networking. The switch do so much work, is so intelligent that you don't understand what is networking if you only work with switch. So look at those are pictures of hub. So for example, if you look at this one, it has 8 ports, which are UTP port, no? RJ45. This is the way where you are going to connect it to the power. And this is another type of connector, which is the BNC connector. So at this time, we have a technology that was 10^2. It is written here. 10^2 is obsolete today, and 10^2 was using coaxial cable. So today, nobody uses coaxial cable for Ethernet anymore, no? So this is another hub. This is the front part. We have 8 ports in the front part. This is the back part. As you can see in the back part, we also have a BNC connector. So we can connect a 10^2 network, which is obsolete today. But we also have a AUI connector. This kind of connector, the AUI, the Attached Unique Interface Connector, was for another network which is called 10^5, which was thick Ethernet. 10^2 is thin Ethernet because the cable is thinner. Thick Ethernet, the cable is bigger. So those two topology those two technology are not used anymore. Thin Ethernet or thick Ethernet are not used anymore, no? So what we use is UTP when we work with Ethernet. So there is something that is important here, that a hub will regenerate the signal, which means that when a device sends something to a hub, according to the distance that the signal have to traverse, it will suffer attenuation, no? And maybe distortion due to noise. What the hub is going to do is going to regenerate the signal, which means that the stereo of 0 and 1 arrive like tired. They lose their strength because they were traveling in the medium. The hub put them again, nice, beautiful, before it sent them. So it regenerates the signal. It regenerates and amplifies the signal, as we can see here. Okay, what you need to remember, a hub is one collision domain, one broadcast domain. It's a layer 1 device. Now let's talk about a switch. It's much more intelligent, as we will see. So this is a switch. This is the symbol of a switch. The switch is a layer 2 device, which means that It operates in layer 1, which is the physical layer, and in layer 2, which is the data link layer. So the switch do have memory. And the switch have a table. A hub does not have a table. This table is called the MAC address table, or the CAM table. CAM for Content Addressable Memory Table. So the switch has a CAM table. And this CAM table, sometimes we will represent it with 2 columns, sometimes we represent it with 3 columns. It have at least 3 columns. So one of the columns will be the port, which will be the incoming port. Another column will be the MAC address that are connected to this port. And another column that here in this table we don't see is the time to leave. For every entry that enter the MAC address table, there is a time to leave, which is the number of seconds that the entry should stay in the table before it is removed. Which means that every time that I put an entry in the MAC address table or in the CAM table, I start a timer. If the timer time out, I did not refresh this entry, I have to remove this entry from the MAC address table. So the switch do 2 operations when it receives a frame. It will learn and it will take a decision what to do with the frame. So let's see the learning process. Those are the steps of the learning process. So by learning, I will put information in my MAC address table or in my CAM table. So here they say the switch add entry in the MAC address table or in the CAM table, depending or based on the source MAC address in the frame. So the process is the following. The switch examines all the incoming frame and look at the source MAC address. So if the source MAC address is unknown, which means that it is not already in the MAC address table, the switch will add an entry in the MAC address table and will start a timer for 5 minutes. 5 minutes is 300 seconds. Now, if the source MAC address of the frame, of the incoming frame, is already in the CAM table, I already have an entry for this MAC address. So what I will do here is to refresh the timer associated with this MAC address, this entry in the MAC address table. So it will stay for another 300 seconds, which is 5 minutes, no? So here they say that most, by default, most of the switch will keep an entry in the CAM table or in the MAC address table for 5 minutes, which is 300 seconds. Of course, you can configure that and you can change it in the majority of network devices that are configurable. No, you can change this value if you want. But the default value, if you do not change it, will be 300 seconds, which is 5 minutes. This is the learning process that we just saw. Now, let's see the process of taking an action, what to do. So a switch has 3 possibilities. It can filter the frame. Filter is to drop the frame. I receive a frame in one of my ports, I am a switch, and I decide to drop it. This is called filtering. The switch can also do commutation. Commutation is when I receive a frame in one port and I forward it through another port. So the incoming port and the outgoing port are different. That will be commutation. And another possibility for a switch is to do flooding. Flooding is that I receive a frame in one port that we will call the incoming port, and I forward this frame in all the other ports. So all the other ports are outgoing ports. So let's see when the switch do filtering, when it's do commutation, and when it's do flooding. So the process is like that. When a switch receives a frame, to take a decision what to do with the frame, the switch will look the destination MAC address. So if the destination MAC address is the broadcast address, or it's a multicast address, remember that the multicast address always starts with 01005E, and this is always the broadcast address, not the multicast, the broadcast MAC address. So if it's a broadcast MAC address or a multicast MAC address, the switch will flood the frame. Flood the frame that it will send it out all the other ports, except the incoming port, of course. Now, if the destination MAC address is a unicast MAC address, the switch will look at the MAC address table to see if it already has an entry for this MAC address table. So if there is no entry in the MAC address table for the destination MAC address, the switch will forward the frame at all the port, which means it will do flooding because it doesn't know where is the destination device. Since it doesn't know where is the destination of the device, it will just flood the frame out all the other ports. Now, if there is an entry in the CAM table for the destination MAC address, there are two possibilities. So I will check my MAC address table, and my MAC address table will give me an outgoing port. So if the incoming port is the same as the outgoing port, according to my MAC address table, I will filter the frame. What does it mean? We are here in this bullet. It means that I will drop the frame because I already know that the destination have received the frame. Now, if the outgoing port is different from the incoming port, I will forward the frame, which means I will send it out over the interface that is specified by the entry in my MAC address table. So this is the process that a switch follows to take a decision what to do with a frame. If it's going to do filtering, commutation, or flooding. We are going to do exercises on that. Unfortunately, it will be when we come back from the break because we will not have time today. But those exercises will make it very clear how a switch works. So here we have a summary of the behavior of a switch. So you see it's much more complex than a hub because a hub always do flooding. A switch can do filtering, commutation, or flooding because it's much more intelligent. And the decision will be based on the MAC address table. So let's see the summary. So the summary about the forwarding decision. To take a decision, I look the destination MAC address. So if the destination MAC address is a broadcast address or is a multicast address, the frame is flooded at all the other interface. So except the incoming interface, of course, no? Now, if the destination MAC address is a unicast address, the switch will look at the CAM table to try to find a match. So if there is no match, we mean that the destination MAC address is not in the table, which means that it's an unknown MAC address, the switch will flood the frame at all of the port except the incoming port. It will do flooding also in this case. Now, if I do have the destination MAC address in my CAM table, so I will forward the frame if and only if the destination or the outgoing port is different from the incoming port. Now, if according to my MAC address table, the outgoing port should be the same as the incoming port, I will filter the frame. I will drop it because I already know that the destination have received a copy of the frame. So this is how the forwarding process works in a switch. Now the learning process is based on the source MAC address. So the switch will examine the source MAC address of the frame. If the source MAC address is unknown, which means that it is not already in the MAC address table, I will add an entry in the MAC address table specifying that this MAC address table enters through this port, and I will assign a timer of 300 seconds. So this entry will be there for at least 300 seconds. Now, if the source MAC address does exist already in the MAC address table, I will just update my timer. So this entry will be there for another 300 seconds, which is 5 minutes. Okay, so in summary, what is a switch? A switch is a device that has several ports and also have a CAM table, which is stored in memory. So the switch will fill the CAM table or the MAC address table based on the source MAC address of incoming frame. Now, the switch will take a decision what to do with an incoming frame based on the destination MAC address. And the switch can do filtering, which is dropping the frame, commutation, which is I receive a frame in one interface, I send it out through another interface, or flooding. I receive it on one interface and I copy it in all the other interfaces. Remember, the hub only do flooding all the time. So the switch have 3 possibilities, while the hub only do flooding all the time. So the switch is a layer 2 device, which means that you have function of the physical layer and the data link layer. So all switch used to be half duplex. They used to only use a pair in the UTP cable to send and receive, which means that all the port of an old switch will be a collision domain, which means that a collision can occur there in the connection between 2 devices when it's half duplex. Now, the whole switch is a broadcast domain. Now, if you take a modern switch, all the ports are full duplex. They use a pair of wire to transmit and a different pair of wire to receive. So modern devices are collision free. They don't have collision. So if you connect to a modern switch, a modern device, they will work full duplex, which means that they will not have collision at all, no? Because they are able to work full duplex. Now, the whole switch is only one broadcast domain, which means that if you send a broadcast through to a switch, it will copy it to all the other interfaces. Okay, there are 2 technologies when you buy a switch. There is a technology that is called store and forward. It's slower. And there is a technology that is called cut through. It is faster. And this category, we will see that we can divide it in 2 subcategories. So what is the difference between store and forward and cut through? So store and forward is a little slower. So when there is an incoming frame, the switch will wait to receive the whole frame and will store it in memory. Once the store has been totally received, the switch is going to compute the CRC. If the CRC that the switch computes is different from the CRC of the frame, there were a transmission problem. So the switch is going to drop the frame. Otherwise, if the CRC is okay, the one that I compute is the same as the one that I receive, the switch will forward the frame normally. So according to the destination MAC address, it will do filtering, commutation, offloading. Now, what is a cut-through switch? It's faster. It will not store the whole frame before taking a decision. So it will start as soon as it receives enough information to take a decision. It will take a decision what to do with the frame and will not wait to receive totally the frame. It is still receiving the frame when it starts propagating the frame. It's why it's much faster. Now, the fact that it's much faster comes with a price. We have to pay a price. And the price is that this kind of a switch will not compute the CRC, which means that if they receive a frame that have suffered interference in transmission, which is a frame that should be dropped, they will forward a frame that have problem because they don't wait until the end of the frame to compute the CRC. They don't compute it at all. They want to be fast, so as soon as they can take a decision, they take a decision what to do with the frame, so they are very fast. In the cut-through, we have two subcategories. We have one that we will call fast-forward switching. The majority of them are like that. They are very, very fast. As soon as the first field of Ethernet is the destination MAC, which is the first 6 bytes. No, we saw that in previous frame. Let me show you again. It is there. This is the first field, which is the destination MAC. So as soon as I have received the destination MAC, let me go back to the slide. So as soon as I receive the destination MAC, I will take a decision what to do with the frame based on my MAC address table. So it's very, very fast. But the bad thing that if the CRC is not good, I will forward a frame that is not good. I'm very fast, but if I receive a corrupt frame, I will forward a corrupt frame. Now, the difference here is that the switch will wait the first 64 bytes. Why? Because if a frame have a length that is smaller than 64 bytes, it is considered as part of a collision. So those are still fast, but they are able to remove frame that correspond part of a collision. Those are very fast, but they will, if there is a frame that is part of a collision, they will propagate, they will forward this frame that is part of a collision. So this is the difference. It's a trade-off between being very fast and forward thing that I should not forward, because they are not they are frames that have suffered interference or frames that have been in collision with other frame. Okay, at the level of the memory, I did say that switch have memory. Some manufacturer or some model of switch will have distributed memory. They have memory assigned to each port. So when there is an incoming frame, if they cannot process it right away, they can store it in the memory of the incoming port. Then they will process the frame and copy it in the memory of the outgoing port. And when they have a possibility to send a frame, they will send a frame. All the switch use sharing memory, which is a central memory for the whole switch. So we don't have memory at the level of each port, but a central memory. So all incoming frames, will be stored in the central memory. And they will be taken from the central memory when they are sent. So this is two different philosophies, and both have advantage and disadvantage. Now, there is something that we call half duplex and full duplex. So remember, half duplex is when in the UTP cable we use only one pair to send and receive. So all devices were half duplex. But all new devices are full duplex. So in the UTP cable, they use two pairs, one to send, one to receive. So when you connect two devices, it is important that both devices use either half duplex or full duplex. So if one device only supports half duplex, the other device that support both have to go to half duplex and work in half duplex. Now, if both devices support full duplex, we better work in full duplex, no? So you have to avoid the situation where you configure one port in full duplex and the other port in half duplex. You should not have that. Remember that full duplex Ethernet is free of collision. Half duplex Ethernet will have collision because we have one pair to send and receive. Full duplex Ethernet have two different pairs. So this is a problem, no? And this is a common reason of problems in a network, that in a connection, one of the device use half duplex and the other device use full duplex. By using full duplex, you are free of collision, and of course, your performance will be much higher because at the same time you can send and receive because you have different pair to send and receive, no? There is other thing that is called MDIX, medium dependent interface crossover. So if you remember, what kind of cable should I put if I connect two switches back to back? A crossover or a straight through cable? We saw that, no? If you connect two devices of the same type back to back, like for example here, if I connect two switches, the cable should be a crossover. Now, if I connect a switch to a router, what kind of cable should I use? A straight through. Now, if I connect an end device to a switch, what kind of cable should I use? A straight through. So all devices were not, the ports were not intelligent. And you do have to be very careful in all devices to put the correct cable. New devices support what is called auto MDIX, medium dependent interface crossover, which means that they are able to negotiate and to change the topology, which means that in modern devices that support auto MDIX, the cable that you use is not a problem. You can use a point-to-point, you can use a straight-through cable or a crossover cable. But if you use the incorrect cable, the two network devices that are connected through the UTP cable will make the correction for you. This is what it means. So this is in modern devices. All devices did not support auto MDX, and I have to do the MDX manually with command. But modern devices do support it. Okay? So another thing that is important also, that when you connect to devices, modern devices will work to the highest bandwidth that they support. So let's say that you connect a device that supports 10 Mbps or 100 Mbps with another device that supports 10, 100, and 1000 Mbps. They will automatically work at the highest speed that they both support, which is 100 Mbps. But in all devices, I did have to specify manually the speed that I wanted them to work. Today, everything is automatic. They are intelligent, their ports are intelligent, they are able to negotiate if they are going to use 10 Mbps, 100 Mbps, 1000 Mbps. And of course, they will always use the better one that both support. Here is a summary of what is a router, what is a switch, and what is a hub. So a hub is a layer 1 device. It's only work in the physical layer. So the whole hub is one collision domain, which means that all the stations that are connected to a hub, only one can transmit at the time. And the whole hub is one collision domain. Now, a switch is a layer 2 device. So the whole switch is one broadcast domain. Now, according to the port of the switch, so each port, we have to think about each port. If the switch is totally half duplex, each port will be one different collision domain. Now, if the switch is full duplex and you connect another device that is full duplex, in this link, the switch are going to work full duplex, which means that there will be no collision. And the same thing happened with the router. The router is a layer 3 device. It has a routing table. The switch have a MAC address table or a CAM table. So the router is, each interface of the router is a different broadcast domain, because we connect different network in each interface. Now, router can be old or new. Old router, the port of the old router, the Ethernet technology was half duplex. So each port in this case will be a collision domain. Now, new router, the Ethernet port are full duplex. So if you connect another device that is full duplex, they will use full duplex, and they will not have a collision in this link. Okay, I'm done with this. We can do some exercises. So I'm going to continue with the exercises that we were doing. And when we come back, we will do exercises to understand the difference between a hub, a switch, and a router. So let me go back to exercises. We were, I think we finish in where did we finish last time?
I think it was 55.
55? Yeah, I remember that we saw this one. Okay, we have to start in 55? Okay. So 55, question 55. What are two functions of a router? So a router connects multiple IP networks. This is true. Through each interface, you will connect a different network. So a router connects together different network, different IP network, no? So a router controls the flow via the use of layer 2 addresses. Is this true or this is false? How do a router work? It looks at the destination IP address on the routing table. So a router takes a decision based on the destination IP address. So that is not true. Who takes a decision based on the destination MAC address? A switch. So you see the switch work in layer 2. So the switch look the destination MAC address to take a decision. The router work in layer 3. So the router take a decision based on the destination IP address to decide where to forward the packet. Okay, so this is the job of a switch. This is not the job of a router. The router work in layer 3, so it work at the level of IP address. The switch work in layer 2, so it work at the level of MAC addresses. So let's see this possibility. It determines the best path to send the packet. That's true. Okay, the router determines the best path. Okay, so router can be statically configured or can be automatically configured with dynamic routing protocol. It provides segmentation in layer 2. So look, segmentation is cutting in chunk. When I talk about segmentation, I am in which layer? Layer 4, correct. When I talk about fragmentation, I am in which layer? Layer 3, correct. So both of them are cutting in smaller chunks. But in layer 4, which is the transport layer, we call it segmentation. And in layer 3, which is the network layer, we call it fragmentation. Okay. It built a routing table based on ARP request. So the router built a routing table, but it's not based on ARP request. It is based on a dynamic routing protocol, such as RIP, Routing Information Protocol, or OSPF, Open Shortest Path Protocol, or ISIS, Intermediate System, or EIGRP, Enhanced Interior Gateway Routing Protocol. So it does construct a routing table based on dynamic routing protocol, no? Question 56. In order for packet to be sent to a remote destination, there are 3 pieces of information that must be configured in a host. Choose 3 options. So when you configure a PC that will be able to send packets to a remote network, what do you need to configure as a minimum in the network device, in the PC? What is the minimum information that you need to configure? Between all this information. Of course, I need an IP address. I cannot be in a network if I don't have an IP address. What else? The subnet mask. You remember we saw the slides when we configure a Windows machine. We cannot avoid that. We need to put the IP address. We need to put the subnet mask. What else we need? The default gateway, correct. So the other are optional. So for example, the host name is not very important in a communication. What is a DNS server? It's a service that will allow me to resolve a host name into an IP address. Something like www.jsu.edu to an IP address. So if in a computer you don't configure the DNS server, you will still be able to walk, but you will have to put manually the IP address. You cannot put names. You need to know the IP address, which is a lot of work for us to know the IP address. So what we use the service DNS. DNS server address. When you configure DHCP server address, when you configure DHCP, you don't specify the DHCP server. When the station that needs its configuration parameter boot, it has to discover the DHCP server. To discover it, it will send a broadcast, which means it will send a frame or a packet, I should say, to all the stations that are in the local area network. And only the DHCP server is going to answer this broadcast. So it doesn't communicate with a specific DHCP server. It has to discover the DHCP server. Question 57. What are two advantages of static routing over dynamic routing? Choose two options. So let's see A. Static routing is more secure because it does not advertise over the network. That's true. If I do static routing, the router do not have to communicate between each other to exchange information. Since they don't communicate, it's more safe because there is no exchange of information between the router. If we use a dynamic routing protocol and somebody captures the traffic in one of the interface of the router, the person can get information of the topology because, of course, the router changed topological information about the topology. So they know how is the network done. So that's true. The first answer is true. If you use static routing, you will not exchange information, so it's more safe. Static routing scale well with expanding network. What do you think about that? Let's say that you decided not to use a dynamic routing protocol. You manually configure your router. Is this going to scale well? No. Because every time that you do a modification in your network, let's say you add a new network, you need to go over all the router and reconfigure them, add new information to them. So it's at one point it will be a lot of work. So static configuration is okay in small network, but not in big network. Not recommended at all. It's too time consuming. So it does not scale well because it's too time consuming for the administrator. So static routing requires very little knowledge of the network for correct implementation. That's not true. You need to know all the network. In dynamic routing, when you configure a router, you need to have very little knowledge because they will talk to each other. The router will talk to each other, exchange information, and they will discover the topology of the network. They will discover remote network. But in static routing, I have to tell everything to the router so it knows what is remote, what remote network exists and how to reach them. So I need to know all the knowledge. So C was not true. What about D? Static routing uses fewer router resources than dynamic routing. What do you think? Yeah, it's true. Why? Because you don't have to run a routing protocol. If you use dynamic routing, you need to run an additional process that communicates with the remote router and exchange information. So you put more load on your router because you run a dynamic process, a dynamic routing protocol process, no? So this is true. The last one, which is it, should be false. So static routing is relatively easy to configure for a large network. No, it's very complex, because you have to say all the details. And if you have redundancy, it's even more complex. If you don't have redundancy, it's straightforward, because there is only one way to reach another place, a remote network. But if you have redundancy, you have several paths. So you have to think about what you are going to do. Question 58. What is a characteristic of static route that match all packets? How we call that? The route that match all packets. The default route. How it is represented? 0.0.0.0/0 or 0.0.0.0/0.0.0. If I say the MAC address in the dotted decimal notation, no? Okay, so it say A. It back up a route already discovered by a dynamic routing protocol. So the default route is the one that we use as the last resource. If we do not find any entry that match, we will take the default route. So it's the last possibility, the last option. I didn't find a more specific route, so I use the default route. So it's not A, no? B, it uses a simple network address to send multiple static routes to one destination address. I think that's not even a correct sentence. C, it's defined a gateway IP address to which the router sends all IP packets, for which it does not have a learned or static route. So this is true. This is what I was telling you, no? If there is no match with the more specific route that I learned dynamically or statically, I will use the default route. But if there is a match or several match with a route that I learned statically or dynamically, I will go with one of these, because the default route is the last resort. Okay, I didn't find any solution, so I use it, no? So it is configured with a higher administrative distance than the original dynamic routing protocol has. So there is something that we call administrative distance. So if the source that make you learn some remote network is very, how do you say that in English? Reliable. If it's reliable, you associate with it a high administrative distance. So high administrative distance show how much I trust a source. So if I trust a source a lot, I put it a high administrative distance. If I don't trust a source a lot, I put a low administrative distance. Normally, the default route have a low administrative distance, which means that it will be the one that we will use only if there is no alternative. No more specific route, no? So the answer was C. What two tasks do dynamic routing protocol? What is the objective of dynamic routing protocol? So discover host. Do they discover host? No, they discover remote network, no? So they don't discover homes. They do discover, but they discover network. So they discover remote network generally, no? So network discovery, they do that. So update and maintain routing tables, yes. A router have a routing table, and through a dynamic routing protocol, they will update, they will maintain the routing table. Propagate host default gateway, that's not true. An end device get the default gateway either manually or through DHCP, but they don't get it through a dynamic routing protocol. Assign IP addresses, no. Who assign IP addresses? A DHCP server. A DHCP server assign network parameter to a station that don't have it. So it will tell the station, your IP address will be this, the mask that you should use will be this, the default gateway will be this, and maybe other parameters, like for example, the DNS server, no? Question 16. When will it be more beneficial to use dynamic routing protocol instead of static routing? So remember, static routing, if the network is small, it's good to use static routing. So if the network is big, or there is a lot of change in the network, topological change, new link that appear or link that disappear, it's better dynamic routing protocol. Because if you do it statically, every time that there is a change, you have to run to all the router and reconfigure them. So you better use the dynamic routing protocol, which dynamically adjusts to the topology change. Now, remember that a dynamic routing protocol do use resources. So you need more memory, you need more CPU power. So if you use dynamic routing protocol, remember your router must be much powerful than if you use static routing protocol or static configuration. So let's see 60. In an organization with a small network that is not accepted to grow in size. So if the network is small, it's better to use static routing protocol, isn't it? So I will not use in this case a dynamic routing protocol. So B, in a stub network that have a single exit point. So if the network is stub, which means that there is only one way to go out to the internet, we don't have redundancy. You can, the best way here, since you don't have redundancy, is to configure static routing, because there is no different way to go out. If I lose the connection to the internet, there is no redundancy. So there is no way for me to reroute the traffic to another exit. I have only one exit or one entry point. So in this case, dynamic routing protocol is not good idea. So C, in an organization where routers suffer from performance issue. Okay, if you have performance issue in your router, don't overload your router with a dynamic routing protocol, because it will consume more memory, more CPU. So the answer has to be D. In a network where there is a lot of topology change, of course, dynamic routing protocol will automatically adjust when there is a topology change. So the network administrator don't have to intervene. This is why the internet works so well. You look, the internet is always on. Why? Because we use dynamic routing protocol. And there are a lot of links that are on now, and at one point they are off. But since there is so much redundancy in the internet, it's not a problem that, let's say that from here to the MIT in this moment, we use a path. And for one reason, they cut this path. I will still be able to connect to the MIT. Why? Because we have other paths. We have redundancy. So if the best path of this moment is cut, I will take an alternate path. The packets are going to take an alternate path. And thanks to who? The dynamic routing protocol. They are able to realize that the best path that they were using is not available anymore. So they will go through another path. Okay? And the network administrator will not have to go at the level of the router and change the information. This information will be updated automatically because the router talk to each other, and each router tell the other router what they know about the topology. So at the end, they know everything about the topology because they talk to each other. Okay, let's stop here. Remember that you have homework number 2, no? That you have to do. So there is a due date. So be sure you submit your solution before the due date, no? And as soon as you define your partner, you can work on the lab. Just one student should upload the report. Be sure you do a good report. Take screenshots. Don't take screenshots that are bigger than they should be. Don't take picture with your camera. I don't accept picture with camera. You can take a screenshot. If you have to write something and you wrote it in the paper, you need to pass it in Word. Don't take a picture of any draft paper like that. That's not serious, no? I see some student, they write something in a piece of paper, they take a picture, they put that in the report. What is that? You have seen that one of your professor take a picture and give you something like that? We don't do that. Okay, we have modern tools like Word. They write equation, they write whatever we want. They do tables. So if you need to do a report, you use the tools that the computer offer you. Okay, and you don't take picture. Okay, enjoy your break. I see you when we come back.